Episode 16. Storage Management Organizing Data in the Digital World. Welcome back to the IT Diary series. In all previous lessons, we focused on how the operating system manages hot, temporary resources such as CPU and RAM, but our data needs to persist even when the computer powers off. This brings us to a critical area: managing secondary storage devices like SSDs and HDDs. To turn a chaotic sea of bits on disk into an organized system humans can understand and use, the operating system provides a powerful abstraction layer called the file system. Today's lesson lays the foundation for this entire domain. Part 1. Basic Concepts of File Systems. Note 201 to 210. 1.1. File Concept. A file is a named collection of related information stored on long-term storage. To the OS, a file is the smallest logical storage unit. It hides the complexity of how and where data is physically stored. Each file has attributes, such as name, human, readable identifier, for example, report.x. Identifier, unique system level. Number 4, example, inode number. Type, nature of the file executable, text, image, etc. Size, current file length, location. Pointer to physical storage blocks. Protection, permissions for read, write, execute. Timestamps, creation, last modification, last access. Analogy, a hospital record, name equals patient's name on the cover. Identifier equals unique patient ID. Type equals inpatient record, outpatient record, X-ray file. Size equals number of pages. Location equals which archive room and shelf. Protection equals only doctors and head nurses may access. 1.2. File operations. The OS provides system calls for basic file operations. Create, make a new empty file, right? Store data at the current file pointer, read. Retrieve data from the file. Reposition, seek. Move file pointer to another position. Delete, remove file and free its space. Truncate, erase file content, but keep attributes. Analogy, a notebook. Create equals open a blank page. Write equals use a pen to add content. Read equals revisit the written content. Seek equals flip to a different page. Delete equals tear out a page. Truncate equals erase the page clean with an eraser. 1.3. Directory structure. Directories group and manage thousands or millions of files. A directory is itself a special file containing metadata about other files. Common structures, single level, all files in one directory, causes chaos and name conflicts. 2 level, each user has a separate directory, solves naming conflicts. Tree, structured, most common. Directories contain files and subdirectories in hierarchy. Analogy, document storage. Single level equals dump all documents on one desk. 2 level equals each employee has a personal drawer. Tree equals a cabinet system root directory per, with folders home/USR, subfolders. Home user, and individual papers files. Part 2. Disk space allocation methods. Note 211 to 220. This answers when a file is created. How does the OS allocate disk blocks to it? 2.1. Contiguous allocation file occupies a set of continuous blocks. Directory stores start block and length. Example, file starts at block 19, length 6 gives occupies blocks 19 to 24. Pros, very fast, sequential, and random access. Cons, severe external fragmentation, hard to grow file. 2.2. Linked allocation file is a linked list of disk blocks. Each block stores data plus pointer to next block. Directory stores starting block. Example, block 9 gives, block 16 gives, block 1 gives, block 10 gives. Pros, no external fragmentation, easy to expand file. Cons, inefficient random access, must traverse chain. Pointer damage can corrupt file. 2.3. Indexed allocation. Each file has an index block storing pointers to all its data blocks. Directory points to this index block. Example, like a book index listing which page each chapter starts on. Pros: eliminates external fragmentation. Fast random access. Cons: wasted space for small files. Large files may require multi-level indexing. Tree-like. Conclusion: today, we built an overview of how the OS organizes long-term data storage. Its files and directories are the building blocks. We examined 3 classic allocation strategies: contiguous, fast, but fragmented; linked, flexible, but slow for random access; indexed, balanced, widely used, for example, IXT for in Linux, NTFS in Windows. In the next lesson, we will dive deeper into file system implementation, exploring free space management, detailed directory structures, and file system performance. See you then.